Hey everybody, so this video is going to go through something called the line of best fit. So in the previous lesson we looked at the different types of graphs, we looked at their characteristics of things like end behavior, domain, range, x-intercept, y-intercept, but the main part of what we are going to do in not only this unit, but also in the next few units, is we are going to be determining what is called either the line of best fit or the curve of best fit. And the way that you do that is, if it doesn't tell you, you're going to have to look at the general shape of what the points are that whatever the data is to determine whether you should be putting a line, whether you should be putting a curve. Maybe it's going to be a quadratic, maybe it's going to be a cubic, but really it's up to you to understand what these graphs look like to determine what the what kind of line or curve we're going to be fitting to this data. So we're going to be just focusing on lines today. So we're going to be focusing on linear. Apparently I don't know how to spell linear, which is they have a degree of 1. So we're going to be looking at just straight lines. So what we're going to be doing is we're going to be given a set of data, so a bunch of points, and we are going to determine the function, which in this case is going to be a line, that best fits the data that is on there. And we're going to be using Desmos to figure that out. So what it's called when we do this is called linear regression. Okay. So there might be, in this case, it's linear regression, but it might be quadratic regression, it might be cubic regression, and it might be up to you to decide. It might not necessarily tell you which one to use. So when we are making a line, just remember that a line, the general form of that equation is y equals mx plus b, where m is my slope and b is my y-intercept. Now again, there is all of this data here, all of this information about how to use the TI-83 calculator. We are going to be using Desmos to do this. So the steps look a little bit different, but again, I think it's quite a bit easier. So what we want to do is we want to click on the plus symbol, and then we want to make a table. Okay, so a table is going to pop up on Desmos. We're going to enter all of our points in. But now this is the key thing, is that on a new line, we're going to type, and you have to type this in exactly like this, y1 squiggle ax1 plus b. So now again, this general form here looks like the general form of just the equation of a line, which is mx plus b. The reason why these ones are here is because when we make a table on Desmos, it's going to have x1 and y1 as the headers of that table. So that's why that's where the ones come from. And then what Desmos is going to do is it is going to tell us the best a value and the best b value that fit our data. So we're going to run through an example and we're going to see what kinds of questions, how do we do regression, how do we make a table on Desmos, and then there are some additional questions that we are going to go through. So this is my example 1. This is my data here. It's split up into 2 separate tables, but this is all one big table. So what we're going to do first is create a scatter plot and then come up with a linear regression line for this data. So what I'm going to do is I'm going to hit pause here. I'm going to plot these points on my graph. If you want to try it yourself, I would highly encourage you to do so, but otherwise we're just going to jump back with those points plotted on my graph. So I have all my points on the graph here. In terms of how I labeled the axes, so every second, I guess, line on the bottom, I just counted up by 2 for those. So basically every line counts up by 1. All the way up to 18, which is my oldest age for the number of years. And then for every second line on the y-axis, I counted up by $1,000. and this represents the price in dollars. So if you are unsure of what this graph is representing, to me it looks like a representation of the age of a vehicle versus how much the car is actually worth. So we get this kind of like downward trend here where the older a car is, the less value it has. So this is what my scatter point looks like when I plot all the points. Now what we are going to do is we are going to take that same table, we are going to put it on Desmos, and we are going to write the regression equation, or not write it, but we're going to come up with the regression equation based on that. And you can see that there are a number of questions that we are going to go through. So what I'm going to do is I am going to switch over to Desmos and show you how to make a table and how to get your regression line. So if you click on the plus, it's at the top left. You click on that. One of the things that is in the drop-down menu is the table. And it comes up with the table with the X1 and the Y1, like I was saying. So for the X1, the X values, I'm going to put the ages, and for the Y values, I'm going to put the prices. Oops, so 4, 6,500, 5, and 7,000. And I'm just going to keep doing this with all of my different values. Also, if you noticed when you were making the table, there was a double value of 6 and 4750. That doesn't mean that you have to draw that point twice. You only have to draw the point once. So if a set of data appears multiple times, it doesn't matter, but it does matter when you put it into your table because it is going to affect your regression calculation just a little bit. So I'm almost there. You can do this as well. I'm kind of just vamping here because who wants to watch somebody type in all of these numbers? It's not the most interesting. 750, 16 is 1000, and 18 is 750. So I think I have all of my data points put in here. Hopefully I do. If not, you're probably going to get a different answer, but that's okay. Okay, so all my points are here. Then what I'm going to do is I'm going to click on number 2, which is underneath, and I'm going to type Y1. And when you type to get the 1 on the bottom like that, you just type Y1. The 1 will automatically do that. And then shift, and the squiggle is at the top left of the keyboard basically to get that. A x1 plus b. And now what you get is you get an A value and a B value. So my A value is negative 477.20574. My B value is 7,847.58852. Also, if we look at the graph here, I mean, all we can really see is a straight line that's going up and down. It doesn't really convey what the line actually looks like. So to get a better visualization, I'm going to click on this wrench tool in the top right, and I can adjust where my x-axis and where my y-axis are. So my x-axis, those were my ages. Those went from 0 to 18, so maybe I'll write from 0 to 20. And my y values, well, they don't go below 0 because we're talking about prices, so it's not going to go below 0. My maximum price that I had was 7,250, I believe, so let's make it to 8,000. And now we can better clearly see, is this 8,000? This looks like 800. I missed the 0. There we go. Now we can better see. So we can see that my line has a negative slope. It has a down right direction. We can also see all of those points that we plotted in. But let's go ahead and take these regression numbers and write them in our equation. Now, just one more thing that I want to point out is my A number goes with my X values. So just like how in my regular slope formula, y equals mx plus b, the number that is with the X is my slope number. So in this case, A is with my X. So A is going to be my slope number and B is going to be my intercept number. So my equation, my regression equation, which it does say to round to 2 decimal places, is y equals negative 477 point, well, if we're rounding it to 2 decimal places, it would be 0.21x plus my b value is 7847.59 if we round it to 2 decimal places. Okay, so I'm just going to switch back to the notes here. And I wrote it in here. So my equation is y equals negative 477.21x plus 7,847.59. What is the slope? So the slope is negative 477.21. But what does this represent? Well, like I said, this appears to be, even though there's like no information about what this actually is, this to me represents the value that you lose for how old your car is. Okay, or like what the value of your car is. So because it is a downward trend, the value is getting lower and lower each time. So what does this negative 477 represent? Well, what it represents is for every step we take to the right, and my steps to the right are my ages of the cars, this is how much value the car loses year after year. So this is the lost or the decrease in value of a vehicle each year. Now again, this isn't accurate for every vehicle in the world, but this would be accurate to the data that we entered. Part C says, what is the y-intercept of our regression line? Well, just a reminder, my y-intercept is always my constant term in a polynomial function. But I believe if we switch back to Desmos, we can actually click on that point and it will pop up for us. I'm just realizing I'm still on the notes here, so I'll switch over to Desmos. So I clicked on the point here, and we can actually click on the y-intercept of that line that we found. So in this case, my y-intercept is at 7,847.59. So what does this represent? This represents the value of a car when the age of the car is 0, which again doesn't necessarily make sense based on our data. I think it has more of a curve to it, which we might get into in our next unit. But yeah, in this case, that's what the value represents. So now in part D says, if you extend your graph or use your line of best fit, after how many years would a car become worthless? Well, there you go. So this is about cars and values. It literally did not say that anywhere in the question. We have to get to part D of this example to actually find that. So again, my prices, my values are my y-axis. So if a car is worthless, that means the value is going to be 0. So basically what this question is asking is, what is the x-intercept of this graph? Because the x-intercept is where my y, or in this case my value, is equal to 0. So after how many years would it become worthless? Well, it will have a value of 0 at 16.44487 years. It does say to round to the nearest whole number, so we could say after 16 years. Part E says, if you extend your graph, what was the approximate new value of the cars that were studied? Well, the new value means that the age of the car would be 0 years. So that is asking us for our y-intercept. So the new value of the cars would be 7,847 and 59 cents. Now part F is where things start to get a little bit interesting. We're not looking for the intercepts for F or for G or for H. Well, possibly for G. I don't know. We'll see. We haven't gone that far yet. But it says, using your line of best fit, how much would a car that is 10 years old likely be worth? Now, we can find any point on this line just by dragging it out, but there is an easier way to find it. And the way that we find that is we say, okay, so the car is 10 years old. I'm going to switch back to my notes here for a sec. So the car is 10 years old. So when we are talking about age, for 10 years, this is on my x-axis. My age numbers are my x numbers. So what this question is asking is, if a car is 10 years old, that means that x is equal to 10. So what we are going to do is on Desmos, on a new line, we're going to type in x is equal to 10 and then find the intersection point, the point where x equals 10 crosses my line of best fit. So we're going to find the intersection point, and that is going to tell us the value of that car. So I'm going to switch one more time to Desmos. I'm going to enter a new line, x equals 10. That's this red line right here. This is where they intersect. So the value of this particular car would be $3,075.53. Part G says, again, we're going to use our line, how much would a car that is 20 years old likely be worth? So again, instead of putting x equal to 10, we're going to put x is equal to 20. So I'm going to switch that here. And now this is where things get a little bit weird, because the intersection point for this is negative $1,696.53. But obviously, like logically, that doesn't make any sense, because why would the value of a car be negative? It can only hit 0. It can't go below 0. There can't be something that is worth less than $0. Okay, and then part H says, if a car is worth $2,800, what is the age going to be? So now we are talking about the value of our cars. And when we are given a value for our cars, value or the price is my y-axis. So what we are going to do is we are going to plug in y is equal to 2,800. And we're going to, again, find the point where they intersect, which is going to tell us the x value, or how old the car is. So I'm going to switch back to Desmos one last time. I'll take out this x equals 20 line. We'll put in y is equal to 2,800. This is the blue line right here that it makes. The point where they intersect is 10.57738 for the x value. So this would be 10.58 years. Okay, so I'm going to switch back to the notes one more time. This is the only example that we're going to be looking at today. It is a very involved process, as you can see. But the main thing is know how to put a table in Desmos, know the format for typing in the regression equation, and then just try to answer the questions as best as you can. All of this takes practice, but this is going to be the main chunk of not only this unit, but the next 3 units that we're going to be doing. So make sure that you become an expert at using Desmos and just solving problems like this.